So yeah, I'm going to do a short presentation on the Earth-Moon relationship, and I'm going to discuss how the moon was formed and a little bit about how it's different from other moons, and also what the Earth would look like if we didn't have a moon. So we can start off with the four main theories of how moons are created. Um, so stars and solar systems are formed when a gigantic cloud of interstellar gas contracts under the gravitational pull of one of its fragments. And in the center of this, the star is formed, and the rest of the dust is sort of pulled inwards, which causes debris to start swirling rapidly around it, and it forms a disk around the young star. Orbiting materials such as planets are condensed within this disk. Under the process in which a planet condenses simultaneously with its moon, which is one of the four main theories of how moons are created, it means that a planet within this disk also forms its own miniature disk of debris that swirls around it. And this material can then condense to form a substantial moon, which is the case with some of Jupiter's largest moons. Another way of creating a moon is by fission, which means that a rapidly rotating protoplanet, the force and speed of a protoplanet's rapid rotation causes material to be thrown out, which can then form a moon. Or a moon can be captured by a planet's gravitational pull after the moon has been formed somewhere else in the galaxy. And the final theory is the impact theory, which means that the moon is the result of an impact where the collision causes debris from the planet to be sent out into orbit, and that later can become one or more moons. So there have been quite a lot of debates around which theory is best suited for the creation of our moon. And in Discovering the Universe by Neil F. Comins and William J. Kaufman, this debate is summarized quite well. The capture theory, which implies that the moon was created elsewhere in the galaxy and then pulled in by Earth's gravitational force, is considered quite unlikely because bodies that are created in different parts of the galaxy have very different chemical makeups, and the moon and the Earth have two similar surface geochemistries for this to be plausible. The fission theory is debatable because there's no evidence that proto-Earth ever rotated fast enough to have the speed and force to sort of flung out debris. So in general, the most accepted theory is the impact theory, and it's also called the collision ejection theory or the large impact theory. And the theory suggests that Earth was struck by a Mars-sized planetary body, and that this collision occurred at an angle. And debris from the Earth's crust combined with fragments from the impactor were sent out to orbit young Earth. And this ring orbited for a short period of time before condensing to form our moon. So this event would have occurred after the Earth had differentiated, which is the process in which denser materials such as iron sink towards the center of a planet and lighter elements are forced upwards, which means that debris from the impact would contain material from Earth's crust and mantle and not its iron-rich core. And there are quite a lot of the moon's characteristics that are explained by this theory. For example, pulverized rock would have lost easily evaporated elements like water, which would leave the moon relatively dry in comparison to Earth. And the fact that the impact occurred after the Earth had differentiated explains why the moon has little iron-rich matter. And a third occurrence that's explained by this theory is the tilt of the Earth's axis. So a large enough object could have, upon impact, tipped the Earth over. So this tilting of the Earth's axis is kind of explained by this impact theory as well, which is why it's largely accepted by astronomers. So if we look at some of the differences between our moon and other moons in the solar system, sorry. So Earth is the first planet from the sun to have a moon. And in comparison to Earth, the moon's mass is very large. Usually the largest moons in the solar system belong to the largest planets. And so in comparison to these these massive planets, their satellites appear to be super tiny. Whereas the moon's mass is like 181 of Earth's mass, and therefore it's been referred to as a double planet, which has quite a huge effect on the size of the tides on the planet. And yeah. And Earth only has one moon in comparison to, for example, Mars, which has two moons, or Jupiter, which has 63 moons. In general, planets that have moons have a number between 2 and 63. So we could explore what would happen if Earth had no moon. So there are four main things that would be affected if Earth had no moon: delayed origins, harsh conditions, rush hour, and wobbling Earth. If we start off with delayed origins, so the prospect of life developing would be much more challenging without the moon's help. The moon used to be approximately 10 times closer to Earth. The moon is spiraling outwards by, I think, 3.8 centimeters a year or something like that. But a long time ago, it was 10 times closer to Earth. And so it was also spinning at a rate 4 times faster than it is right now. And the combination of these factors caused massive tides that moved miles inland and back out every 1.5 hours to pull minerals necessary for the formation of life into the young oceans. And if the Earth had been without its moons, the tides would only be created by the gravitational pull of the sun, which would cause them to be much smaller. So it would have taken possibly billions of years longer for there to be enough minerals in the ocean for life to later evolve. So the second thing would be that the conditions would be much harsher. So the ebb and flow of the Earth's tide put a brake on the rapid rotation of young Earth. And without this phenomena, Earth would still be spinning rapidly and causing continuous strong winds, 50 to 150 miles per hour. And this wind would cause perpetual waves. So the conditions in which species evolved would have been way more violent. And it's impossible to imagine that life could have evolved anyway. It's not impossible to imagine that life could have evolved anyway, considering the incredible way that life has adapted in the most surprising places. However, life would likely look very different from the species of plants and animals that we see today. And perhaps land-dwelling species would have had to develop thick shells or reside underground, safe from the constant winds and harsh conditions. And the third factor is the rush hour. So the physiology of life on Earth has developed in regard to our 24-hour days. So our biological clock, which regulates when we eat and sleep and pretty much any other cyclical routines, are set to this 24-hour day. If there was no moon, the days would be much shorter. And to function in a world with something like 6-hour days, species would have to evolve biological clocks to fit this rhythm, and this wouldn't be impossible. But one can only imagine the impact that this may have had on life. And the fourth factor is a wobbling Earth, because the moon stabilizes our rotation. And so a moonless planet with rapid rotation changes their axis of rotation dramatically over the course of time. The Earth's relatively stable axis of rotation means we have relatively stable seasons. And without the moon, we would pass through periods of time with virtually no seasons, as well as periods of time with extreme seasons, where the sun would even pass over the poles. And as species develop in harmony with their environment, this level of instability may make it difficult for even the ingenuity of adaptation to take any long-term hold of the planet. So that's the end of my presentation. I hope I managed to explore a little bit of how important the moon has been for the creation of life on Earth, and how different Earth would be if the moon hadn't been created. Thank you.